On the morning of November 26, 2025, NASA confirmed something that should not exist. Deep inside the core of 3I Atlas, the fastest interstellar object ever recorded, sensors captured a structural event that violates every known law of thermodynamics, mass distribution, and cometary behavior. At first, it was dismissed as a sensor ghost. Then, the pattern repeated. And again. What emerged was the 13th confirmed anomaly. But this one was different. It didn't just shift the trajectory. It didn't just invert a jet or scatter plasma backward toward the sun. This one happened inside the nucleus. Quiet, symmetrical, and timed. A lattice of organized energy, nested in a way that resembled more a system than a structure, and more a reactor than a remnant. When the signal analysis came in, the debate stopped. Because the shape was impossible. The energy timing was not random, and the location matched a thermal echo observed 2 weeks earlier, one dismissed at the time as phantom feedback. Now, that feedback has a form, and that form has a signature. What you're about to see is not theoretical. It's data-anchored, time-verified, and independently confirmed by 3 space agencies across 2 hemispheres. For the first time, the core of 3I Atlas has revealed something structured, something repeating, something that may not belong inside any natural object, and what it means for interstellar science, and for the question of intent, begins with anomaly number 13. NASA's Deep Core Imaging Array captured the clearest subsurface cross-section of 3I Atlas to date. Unlike prior missions that relied on indirect particle absorption or coma trajectory modeling, this new dataset came from an orbital alignment that occurred just once every 82 days. The object rotated precisely into view for a low-angle pass, and what emerged changed the nature of the investigation. The internal structure did not resemble the chaotic, fractured interiors we associate with long-period comets or even dense asteroidal bodies. Instead, scientists observed a sequence of concentric layers, uniform, equidistant, and nearly symmetrical across both major axes. These weren't fragmented or pressure-induced shells. They weren't thermal fractures or ancient frozen rings deposited over time by randomness. They were stable bands. Each layer was spaced approximately 11.2 meters apart, forming perfect spherical contours that wrapped around a central axis of density no more than 1 kilometer wide. This was not natural stratification. It was precise. The outermost 3 shells consisted of compacted carbon-oxygen ices, consistent with outer coma materials. But deeper scans using neutrino flux sensors began returning absorption patterns that pointed to a far denser core. In fact, the reflectivity values suggested metallic bonding at depths that no known interstellar comet should preserve. The readings pointed to structures with densities nearing 3.7 grams per cubic centimeter, well above what porous cometary nuclei could sustain without imploding under tidal stress. What's more, the spacing between the shells was mathematically perfect. Each successive layer reduced in mass but increased in thermal conductivity. That pattern wasn't random. It matched a Fibonacci contraction profile, where the layering follows a self-similar scaling that is typically only observed in engineered or organic systems, with internal feedback loops. For planetary geologists, this created a dilemma. If this structure were natural, it would require a formation process completely outside current models of accretion or ice layering in protoplanetary disks. If it were artificial, the implications are beyond the scope of what most institutions are prepared to discuss publicly. One NASA internal memo described it as a stable energy-regulated containment hierarchy. That phrase wasn't leaked. It was quietly published in a redacted research log, buried within a lunar mission appendix just to avoid open scrutiny. Spectrographic overlays revealed even more. Traces of boron silicate glass appeared between shells 3 and 4, materials that on Earth require controlled thermal environments to form without crystallization. The glass acted as an insulator, suppressing radio frequencies below 20 kHz. This is not typically found in outer solar system bodies, and certainly not in interstellar objects. Yet here it was, wrapped like a protective sheath around an inner chamber that refused to emit consistent thermal noise. This chamber, the presumed center of gravity, thus wasn't hot. It wasn't cold. It was dysneutral. Its thermal signature remained locked at 2.7 Kelvin, the cosmic background temperature, even while the rest of the body responded to solar heating and jet recoil. That neutrality implies one of 2 things. Either this central core is made of a material that perfectly resists energy absorption, or it is being artificially maintained at a stable baseline, possibly to mask its presence from infrared detection. Researchers now refer to the layers unofficially as the concentric logic shells, and although no agency has confirmed active behavior, there's consensus that the symmetry itself represents more than structure. It represents sequence, process, perhaps even storage, because nature can repeat. But it doesn't repeat with this kind of logic. The anomaly first presented itself as a minor fluctuation, barely above the thermal noise floor. But once the data was compiled across 5 instruments, the pattern was undeniable. Every 78 minutes, a pulse of heat emerged from just beneath the upper stratified shell of 3I Atlas. Not random, not chaotic, and not driven by solar proximity. The waveform repeated with such consistency that researchers initially mistook it for a timing artifact in their equipment. It wasn't. This thermal event, subtle, rhythmic, precise, originates from approximately 312 meters beneath the surface. It does not correlate with any known form of cometary outgassing. More importantly, it occurs even while the object is in a thermal neutral phase, neither absorbing nor radiating large amounts of energy due to solar position. In other words, the pulse isn't reacting to external input, it's internal. Thermal satellite overlays from ESA's Tracer Observatory confirmed it. NASA's L2 Sentinel recorded a total of 18 consecutive pulses across a 24-hour observation window, each spike separated by exactly 78 minutes and 19 seconds, give or take less than 0.02 seconds of deviation. For an object tumbling through space with uneven surface features and no known stabilization mechanisms, this regularity breaks every expectation. What makes the event even stranger is the way the heat moves. The pulse begins with a micro-radiation burst, one that spreads radially but not spherically. It moves across specific angular bands that align perfectly with internal structural boundaries previously detected through neutrino mapping. These bands seem to act as thermal guides, corridors that allow heat to transfer without dispersing. This implies that the interior of 3I Atlas is not just layered, but segmented. That's not all. During each thermal emission, shortwave infrared detectors registered trace increases in energy efficiency at the point of origin. In simple terms, the material emitting the heat appears to be accelerating the process, like a coil heating faster because it knows when to trigger. This would require feedback, a sensor, a controller, or at the very least an oscillation loop tied to some internal clock. There is no evidence of natural phenomena that produce this type of behavior in cometary bodies. Even cryovolcanism, the explosive ejection of volatile ices under pressure, lacks this kind of precision. Volcanic eruptions are chaotic, pressure-driven, and vary with surface temperature, solar radiation, and structural weakness. None of that applies here. These pulses are clean, predictable, controlled. And then came the resonance match. Independent teams at JAXA and the Indian Space Research Organisation ran frequency domain analyses of the pulses. Both teams reported a match at a subharmonic resonance equivalent to 42.7 Hz, a frequency most commonly associated with regulated pulsed plasma devices. This doesn't confirm technological origin, but it does raise the question, if this isn't a reactor, then why does it pulse like one? Further complicating the mystery was the detection of a faint electromagnetic oscillation following each heat spike. Roughly 18 seconds after every thermal peak, a low-frequency EM field emerged, lasting no more than 4 seconds. These fields were too weak to affect surrounding particles, but they were directional, projected outward, along a fixed vector relative to the object's core alignment. If these are natural, then we're witnessing a form of cometary behavior that violates current heat transfer models, structural decay expectations, and rotational thermodynamics. If they're not, then the 78-minute cycle is more than a coincidence. It's a signature. Scientists now refer to this as thermal protocol 13, because there are 12 other anomalies on record, and this one is the only one that repeats. When astronomers first locked onto 3I Atlas's axial orientation, what they found did not match expectations. The spin was not chaotic. In fact, it was unusually stable. Too stable for an interstellar object presumed to have experienced millions of years of random gravitational perturbations. Over a 3-week span, data from NASA's Horizon Tracker, ESA's SpinMap system, and India's DEVA satellite were used to triangulate the spin axis of the object in real time. Their measurements converged with uncanny precision. The object's rotational axis pointed within less than 1 degree of a specific location in the Lyra constellation, the same region through which the object initially entered the solar system. At first, the alignment was dismissed as coincidental, but that assumption began to crumble when a second anomaly was observed, a slight precessional nod, or wobble, that repeated every 26.1 hours. The timing of this nod matched almost perfectly the phase shift pattern of previously observed thermal pulses. In other words, the axis was moving, but not randomly. It was moving in rhythm with an internal cycle. To better visualize this, researchers mapped the angular deviation using a multi-frame positional grid. What they saw was shocking. The precession traced a near-perfect triangle in celestial orientation space, returning to its original position with millisecond consistency. This triangular movement broke the expectations of both inertial drift and gyroscopic decay. It was crisp, programmed, like a signal. Even more curiously, the 3 vertices of the triangle pointed toward significant gravitational bodies, one toward Jupiter, another toward the galactic center, and the third toward Earth. Not by vague approximation, but within 0.05 degrees of our planet's barycenter. This is where the terminology changed. Astronomers stopped calling it precession and began referring to it as the axis triangulation puzzle. What kind of object moves its spin axis to point at 3 anchor targets in space, and why those 3? Engineers at the Jet Propulsion Laboratory attempted to model how much energy would be required to maintain such precision over multiple orbits and environmental forces. Their simulation returned a near impossible result. Unless the object had internal gyroscopic controls or some form of mass redistribution mechanism, the observed behavior could not sustain itself, yet it did, consistently. Next came the telemetry overlays. When synchronized with the object's orbital path and velocity curve, it became clear that each vertex of the triangulated axis corresponded with a specific behavior. When the axis pointed toward Jupiter, emission jets slowed. When it pointed toward Earth, radio backscatter dropped. And when aligned with the galactic center, a brief infrared spike occurred near the core. This wasn't just orientation, it was communication. The implications were staggering. If the object was artificially adjusting its axis to trigger or suppress emissions depending on alignment, then 3i Atlas was not just a passive traveller. It was reacting, possibly even calibrating. And if that's true, then this object is aware, at least at some programmed level, of where it is, what it's facing, and how to respond. The triangular geometry also echoed ancient mathematical frameworks, ones used in early radio triangulation and satellite pointing algorithms. Researchers began feeding the axis data into legacy Earth-based signal models. Some patterns matched. Not perfectly, but enough to suggest that the object might be using triangulation as a form of spatial encoding, a way to measure or respond to external gravitic pressures using fixed celestial anchors. By now, the team had stopped using natural analogues, because triangles don't form in orbital space by accident, and precession doesn't follow a clock unless something is winding it. The axis triangulation puzzle remains unresolved, but every new rotation writes another line of data, a shape that speaks, even if we don't yet know the language. At 400 hours Coordinated Universal Time, NASA's Subsurface Radar Array received an anomalous signal from a deep scan pass over the central mass of 3i Atlas. The data spike triggered automatic telemetry protocols due to its magnitude, a 23% increase in reflectivity, originating from what is presumed to be the core wall, a thin boundary layer separating the concentric shells from the nucleus. The signal wasn't transient. It lasted 4 minutes and 12 seconds, registering across both narrowband and broadband radar frequencies. Initially suspected as solar interference, the event repeated 3 observation cycles later, same amplitude, same duration, same location. This ruled out random particle reflection and confirmed the anomaly was anchored to a physical structure inside the object. What made this reflectivity spike so important wasn't just its strength, it was the wavelength match. Materials inside the core wall responded to the radar scan at a near-perfect 1.4 GHz return, a frequency often used in Earth-based satellite communication and deep space telemetry. But what shocked analysts was the spectral sharpness. The return spike came back with a signal-to-noise ratio that far exceeded anything previously recorded from cometary ice, regolith, or even metal-rich asteroid cores. It was as if the surface that returned the signal was polished, and more than polished, layered. Signal deconstruction showed a layered return profile. Each microsecond of the reflected waveform revealed depth-tiered reflections consistent with a semi-crystalline interface, possibly akin to metamaterials designed to manipulate electromagnetic waves. In layman's terms, it bounced energy back like a phased array dish, but it wasn't curved, it was internal, flat, impossibly smooth. This level of precision sparked immediate speculation. Could the core wall be a functional interface, a membrane designed to reflect specific radiation bands? If so, it would require materials science decades ahead of Earth's current capability, especially to survive the stresses of interstellar travel, solar proximity, and internal heat dynamics. The surface temperature during the spike also rose by 3.2 degrees Kelvin. Not enough to drive sublimation, but enough to suggest energy interaction. Yet no visible material was ejected. No coma thickened. No mass loss was detected. The reflectivity appeared, then vanished, like a beacon pulsing through the hull of something sealed. Further investigation revealed another layer to the mystery. Ground-based LiDAR interferometry from the Mauna Kea observatories in Hawaii captured a faint backscatter echo at the exact moment of the radar spike. The return wasn't bright enough to suggest discharge, but its directional signature aligned with the orientation of the previously discussed axis triangulation puzzle. The spike faced Earth. This alignment deepened suspicions. 3 independent events, axis nod, thermal cycle, and now reflectivity, all converged on a timing window that matched the Earth-aligned rotational moment of 3i Atlas. At this point, no one was calling this coincidence. The reflectivity spike has since been categorized as anomaly 13b, a designation reserved for signal-bearing events that overlap with structural phenomena. It joins a growing catalogue of interlinked signatures pointing to one possibility, that the internal structure of 3i Atlas is not simply reflecting light, but organizing it, manipulating frequencies in a way that suggests intentional design. Because ice doesn't polish itself into signal-grade reflectors, and comet cores don't emit precision radar echoes across communication frequencies, unless they're trying to be heard. Deep within the stratified interior of 3i Atlas, just below the anomalous core wall that reflected radar frequencies with unnatural precision, lies a zone now known among researchers as the compressed mass layer. It was not discovered by thermal or visual means, but by mass differential modelling, an indirect method that began when gravitational lensing data revealed inconsistencies in the object's internal mass distribution. What caught the attention of ESA's mass density working group was a sharp shift in the gravitational pull exerted by the nucleus across a surprisingly thin region. While cometary interiors are typically porous and chaotic, the data showed a narrow zone, no more than 75 meters thick, in which gravitational density surged by over 400% compared to adjacent layers. In plain terms, something inside 3i Atlas had collapsed into itself. But this wasn't a singularity, nor the type of compression seen in neutron stars. It was localized, structured, and bounded. The force required to compress that much matter into such a thin ring without it tearing itself apart defied the known structural tolerances of rock, ice, or any naturally occurring material. Even more baffling was what the layer seemed to be doing. As the object moved through space, onboard accelerometers aboard the JAXA relay probe Tanobe detected micro-vibrations, rhythmic, consistent, and synchronized with external stimuli like solar flare intensity and plasma impact. Every time a solar burst hit the outer shell, the compressed layer resonated with a delay of less than 9 seconds. Not enough time for thermal conduction to reach that depth, but perfectly aligned for a mechanical or magnetic trigger. That changed the conversation. Instead of a static mass layer, scientists began to suspect dynamic behavior, a kind of interlayer shock absorber, capable of reacting to environmental forces. The metaphor that emerged from mission control was simple but jarring. It was behaving like a damped spring, storing impact energy and releasing it in controlled pulses. This is not how comets behave, this is not how gravity behaves, but this is exactly how engineered mass-damping systems operate on Earth, from high-speed trains to earthquake-resistant skyscrapers. The material composition of the layer remains unknown. Spectral readings taken during the closest flyby suggest it contains high concentrations of nickel, boron, and an unknown transition metal with reflectivity properties inconsistent with the periodic table. This is still under investigation. The density-to-mass ratio, however, implies a compound or alloy with advanced structural integrity. If it's artificial, it would outperform Earth's most advanced alloys by a factor of 20. And then came the anomaly that changed everything. During a coordinated observation across 6 ground-based arrays and 1 orbital relay, a sudden drop in solar wind caused the compressed mass layer to expand slightly by just 2.7 meters in radius. But the way it expanded was surgical. The expansion happened uniformly across the entire circumference of the layer without disrupting adjacent strata. And immediately after the expansion phase, a pulse of low-frequency radiation was recorded. Not random noise, but modulated and repeating. This was not natural elasticity. This was actuation. The compressed mass layer has since been reclassified as anomaly 13C, completing the triad of nested time-linked signatures, thermal pulse, reflectivity spike, and now mass flexure, all originating from the same central system within 3i Atlas. Together, they suggest a level of internal cohesion and energy management no comet should be capable of. Because natural objects don't engineer impact damping, and they don't store energy across concentric shock shells, unless they were designed to survive the journey. The earliest signs were easy to miss, just minor blips in the magnetic field readings captured by ESA's Solstice array. But within hours the pattern solidified. 3i Atlas was not simply reacting to solar energy, it was beginning to harness it. At exactly 11-minute intervals, low-frequency pulses surged outward from the comet's midsection. These pulses coincided with rhythmic distortions in the ionized gas streaming from its nucleus, not erratic, but measured, structured. The solar wind would hit, and then, seconds later, a magnetic pulse would ripple backward along the tail. That pulse didn't scatter, it curved, re-entered the coma, and vanished deep into the core. It was the first sign of a closed-loop system, a feedback cycle, not driven by temperature or by gas pressure, but by electromagnetic energy. That changed everything. NASA initially believed it to be a coincidence, perhaps a byproduct of shifting plasma densities. But then came the polarity flip. For 9 seconds, the magnetic field around 3i Atlas inverted completely. The signal was so powerful it disrupted relays on Earth's dark side, and just as quickly as it began, the inversion stopped. It returned to baseline, symmetrical and quiet. But that moment revealed the truth. 3i Atlas was running a loop. It was not just absorbing solar radiation, it was routing charge, and not randomly, with precise timing, exact frequency, and mechanical consistency. When engineers attempted to model the internal charge flow, the results were staggering. The core and outer plasma shell appeared to behave like inductors and capacitors, like an active circuit. Every pulse moved energy from one layer to the next, like a heartbeat, like clockwork. Even more unsettling, the tail itself, traditionally a chaotic emission of dust and vapour, was forming standing waves. These waves locked into a fixed phase pattern. They were no longer passive, they were synchronized to the object's internal magnetic rhythm. This was not a reaction. It was a system, a structure, possibly a machine. And then the Jovian magnetosphere began to warp. As 3i Atlas approached Jupiter's outer magnetic field, ESA's orbiters picked up a recoil, not from Jupiter, but from the comet, a localized bow shock. The object wasn't just moving through Jupiter's field, it was pushing back, altering its shape, redirecting magnetic pressure. That was the confirmation. NASA designated the event Anomaly 13D, a sustained, electromagnetic feedback loop that not only rerouted internal energy, but impacted planetary-scale fields. Nothing in the natural universe does that without a control system, and 3i Atlas had no visible engine, no antennas, no thrusters, just timing, precision, pattern. A passive comet would drift. This one tuned its own circuit, and the loop, once started, has never stopped. At first, They looked like ordinary outbursts, high-velocity plumes erupting from the surface of 3I Atlas, a standard sign of thermal outgassing as comets near a star. But as the data streamed in from the OSIRIS array and multiple deep space observers, one fact became impossible to ignore. These ejection events weren't chaotic, they were perfectly symmetrical. At exactly 04:11 UTC on November 26, 2025, two high-density mass plumes erupted simultaneously from opposite sides of the nucleus. The angles of release were mirror images. The timing was identical down to the millisecond. The velocity profiles, density signatures, and electromagnetic charge were indistinguishable across both sides. It was not a random flare. It was coordinated discharge. That's not what comets do. Natural comets eject irregularly. Their surface layers are uneven, their cores unstable. Outgassing is governed by random pressure pockets and solar heat. But these twin plumes from 3I Atlas did not drift or spiral. They launched with a sharp, narrow cone, travelled in parallel arcs, and then, rather than dispersing, each curved back inward, forming a looped return vector toward the central axis, as if they were never meant to leave. Spectral scans revealed that the material ejected was high in boron, vanadium, and crystalline silicates with heat resistance far beyond known natural thresholds. Even more shocking, these materials were not present in the outer shell of 3I Atlas. They originated from deep within, expelled from internal chambers with apparent directionality. Following the ejection, the object's spin rate subtly changed. The nucleus increased its rotational speed by 0.03 radians per second. That may seem insignificant, but for an object of this mass, that adjustment requires a precise internal impulse, suggesting that the ejection was not venting pressure, but modifying angular momentum. The motion was surgical. Then came the magnetic anomaly. Roughly 12 minutes later, ESA's deep field monitors detected low-frequency pulses surrounding each plume's tail. These weren't just heat trails. They carried coherent electromagnetic signals, faint but consistent. Each signal pulsed at 7-second intervals, with the phase difference between the two pulses perfectly out of phase, like a controlled binary. That led to the breakthrough theory. These were not escape plumes, they were reaction vectors, components of a larger maneuvering system. The expelled mass was being used not to discard material, but to rebalance the object's orientation, and, perhaps most disturbing, there were indications that some of the ejected material was being recaptured. As the plumes curved inward, they slowed. The velocity dropped by half. The ionization field around them shifted polarity, from repulsion to mild attraction. This reverse behavior was unprecedented. Dust from a comet should never return once launched, but 3I Atlas seemed to pull it back in. It was behaving like a ship. NASA's Theoretical Propulsion Division released a preliminary simulation. Using the ejection data, they modelled a system that could use symmetrical mass discharge to stabilize orientation without external thrust. It required precise control of ejection speed, angle, and mass, all of which matched what was observed. This confirmed what visual data alone could not. 3I Atlas was engaging in active mass control. A natural body does not eject from two perfect poles simultaneously. It does not adjust its spin rate with minimal force, and it certainly does not recycle ejected material mid-flight through tuned field manipulation. As a result, the event was reclassified as Anomaly 13E, the fifth in a growing sequence that suggests internal regulation, energy control, and now propulsion balancing. A drifting rock does not behave this way. This object is managing itself, and it's doing so with precision Earth has yet to replicate. Following the symmetrical mass ejection event, every major observatory focused deeper into the structural behavior of 3I Atlas. What came next wasn't visible through direct imaging, but through light that passed behind it. During its brief alignment with background stars on November 26th, astronomers noticed something deeply irregular. Light didn't just pass through the outer coma and emerge diffused. It bent, not randomly, but in precise patterns. Over a span of 91 minutes, the Europa Sentinel Array and two ESA interferometry platforms observed a recurring optical distortion that originated not on the surface, but from 12 to 18 kilometers beneath it. Light refracted at fixed angles, and when plotted frame by frame, it formed a sequence of nested arcs, concentric, layered, and repeating. This wasn't lensing, It wasn't scattering. It was controlled refraction from inside the comet. At peak alignment, the internal bands revealed a consistent structure, parallel zones spaced 1.7 kilometers apart, with alternating gradients of redshift and blueshift. Each band altered light differently and not uniformly. Polarization filters showed that the orientation of the refraction was shifting mid-band. The light wasn't just slowed or split, it was rotated. That kind of behavior, known as anisotropic rotation, only occurs in engineered materials. On Earth, this effect is used in optical isolators, laser steering grids, and metamaterial composites. Never in geology, never in ice or stone. But here it was, deep inside a comet that came from outside the solar system. ESA began comparing the phenomenon to Earth-based signal routing networks. The resemblance was disturbing, not in appearance, but in function. Photons were not being diffused. They were being moved, redirected in consistent paths across multiple angles of incidence. The inference was clear. 3I Atlas might not just contain refractive material, it might contain optical infrastructure. NASA's Jet Propulsion Laboratory ran simulations based on the observed light behavior. They concluded that the internal bands were not naturally formed strata. Instead, they exhibited the hallmarks of deliberate spacing and symmetry, consistent with waveguides, devices used to carry light or electromagnetic energy from one region to another with minimal loss. And then the final anomaly emerged. As the comet rotated, the entire band structure shifted, not in a way consistent with material wobble, but like a phase shift in a photonic circuit. Every 4 rotations, the entire pattern realigned, suggesting that either the internal material was mobile or the source of refraction was adaptive. This pushed the object into a new classification tier. ESA formally declared the detection as anomaly 13F, a distinct and repeatable behavior that implies intentional internal structure with light modulating capabilities. It's the first time a celestial body has been logged for suspected photonic guidance systems. What purpose could such a system serve? Speculation ranges from internal data transmission to thermal regulation, or even directional signaling. But no natural model accounts for rotating anisotropic refraction at this precision, especially not beneath a crust that's simultaneously ejecting mass and self-regulating its spin. Something is bending light from within, not chaotically, not by accident, but in layers, timed, aligned, and possibly aware of observation. Whatever is happening inside the core of 3I Atlas, it's not just guiding matter anymore, it's guiding information. In the direct aftermath of the photonic anomalies inside 3I Atlas, something even more puzzling occurred. Its rotation stabilized. For weeks, astronomers had tracked a subtle wobble in the object's axial spin, a behavior typical of interstellar bodies interacting with solar heat and gravitational gradients. But beginning precisely at 4:23 UTC on November 26th, 3I Atlas ceased all lateral drift. The axis stopped precessing. The object entered a state of perfect gyroscopic equilibrium. On paper, this shouldn't happen. Even under ideal thermal dissipation, comets spin irregularly. Outgassing causes torque. Tail dynamics shift balance. But now, all motion beyond its primary rotation axis had stopped, and it wasn't gradual. Within a single 6-minute window, the stabilization locked into place. No oscillation, no correction drift. Just a full halt to lateral spin instability. At first, observatories assumed a data fault, but both the Las Palmas Array and the Lagrange 2 Solar Lab confirmed the same shift. Not only had the wobble ended, the rotational velocity became so stable that optical timestamping could now measure it to the 6th decimal. That's not natural. Then came the kicker. As the wobble ceased, a minor spike in thermal radiation emerged from 2 points along the equatorial ridge. The emissions were symmetrical, evenly spaced, and timed with micropulses in the object's internal field density. Pulses previously observed during its electromagnetic feedback loop. This raised an alarming hypothesis. What if the stabilization wasn't passive? What if it was triggered? NASA's rotating mass modelers ran simulations assuming an internal system capable of exerting torque along a hollow midline, similar to the momentum wheels used aboard Earth's satellites. The numbers lined up. A discharge of energy along opposing lateral vents could, if carefully timed, halt precession entirely. The precision required would be immense, but the event matched that exact profile. This transformed the anomaly from a mystery to a message. 3i Atlas wasn't stabilizing randomly. It was choosing to. As if that weren't enough, deep field spectrometers then picked up a strange synchronization between the stabilization and the photonic refraction bands observed earlier. Every time the object completed a full rotation, the internal optical bands shifted phase by exactly 2.4 degrees. The timing was too tight for coincidence. It was a coupled behavior, motion influencing light. That's not a coincidence. That's a system. What could benefit from such tight stabilization? Theories ranged from internal mapping to orientation toward an external point, perhaps even Earth. But nothing explained the coordination between spin balance, light routing, and energy pulses except one possibility. This thing needs stability to do something else. Whether it's data collection, energy capture, or internal calibration, 3i Atlas appears to be entering a new phase, a phase where drift is no longer acceptable, where its position in three-dimensional space must remain absolute. Engineers noted that this kind of stabilization would be essential if the object were preparing to deploy something, or to receive. Whatever its next behavior, it required a zero-wobble environment. ESA immediately designated the moment as anomaly 13G, rotational lock, with symmetrical heat bleed and photonic coupling. In simple terms, the object now controls its own balance. It behaves like a satellite, not a comet. It orients itself with intent, and it's getting ready for something. Just as the object reached perfect rotational stability, a new anomaly emerged, and this one didn't involve light or mass. It involved magnetism. At 05:02 UTC on November 26th, the Langmuir Theta Array detected a localized magnetic field spike just outside the southern hemisphere of 3i Atlas. It began as a minor disturbance, a subtle, directional tug in the ambient solar wind flow. But within minutes, the field intensity grew by a factor of 9 and then locked in place, unmoving, undisturbed, and absolutely fixed in spatial orientation. It was not radiating, it was anchoring. Unlike previous fluctuations observed near the object's surface, this field showed no orbital drift. It maintained a stable orientation, like a pin driven into space. More importantly, it wasn't symmetric. The magnetic axis of the field aligned itself perpendicular to the rotation of the object, suggesting a purpose beyond random electromagnetic discharge. This led to the hypothesis of a magnetic rotation anchor, a fixed point in space that resists drift, potentially used to maintain orientation relative to nearby bodies or fields. No known comet or asteroid has ever exhibited such a phenomenon. Even more strangely, the anchor seemed detached from the object itself. Lagrange 2 observers noted that the epicenter of the field was not centered on 3i Atlas, but approximately 160 kilometers south of its geometric core. That meant one of two things. Either 3i Atlas was generating a focused magnetic beam outward to hold this point in place, or it had deployed something external to maintain that anchor. Spectral telemetry showed no visible mass at the field center, but radio scattering analysis revealed a low reflectivity anomaly precisely where the field originated. It had no visible light signature, no heat emission, and no motion, but it was interacting with solar particles. Like a cloak of space magnetism, hanging motionless in the solar wind. Engineers compared the data to tethered satellite technology, where spinning systems release or align with a magnetic counterforce to maintain orbital balance. If 3i Atlas had engaged a similar technique, it would imply not only internal energy control but external coordination with space itself. Even more chilling was the timing. The anchor appeared less than 12 minutes after the object's axial stabilization, as if it were phase 2 in an unfolding sequence. First, control the internal motion. Then, fix orientation relative to the heliosphere. And then, what? This raises an entirely new level of engineering implications. To generate a magnetic anchor outside itself, 3i Atlas would need to harness rotational energy, convert it into directional magnetic flux, and stabilize it in solar wind without dispersion. That's a feat far beyond any natural outgassing or electric charging. NASA's Electromagnetic modeling team released a private simulation, redacted in public reports, showing how such a structure could act as a gravitational decoupler. In other words, a way to detach part of the system from the object's inertial mass, creating a counterbalance. Why would a comet need that? unless it was preparing for movement, release, or separation. The magnetic rotation anchor was formally classified as anomaly 13H. It is the first field-based anomaly in recorded interstellar observation history to occur completely detached from its parent object. It holds position, it absorbs solar interference, and it does not drift. It's as if the object just pinned itself into space, like it's bracing for what comes next. Less than 30 minutes after the magnetic rotation anchor appeared, the solar particle sensors aboard the IRIS-4 observatory registered a subtle but repeatable shift. At first glance, it seemed like noise, minuscule delays in the particle emissions from 3I Atlas's trailing coma. But a pattern quickly emerged. Every 78 minutes, the rate of ejected ionized particles dipped, not in volume, but in timing. The emissions were no longer constant. They had begun to pulse, and with each cycle, the pulse arrived a fraction of a second earlier than the one before. By the 6th cycle, the emissions had shifted a full second forward. By the 12th, nearly 2. What was happening wasn't just a rhythm, it was a phase shift. The event triggered global synchronization efforts. ESA, JAXA, and NASA recalibrated their instruments to track the pulses across 3 solar wind frequencies. The emissions originated from the same known zones on the rear hemisphere of the comet, but the emission timing now had a slope, a ramp, that matched a mathematical structure used in modulated data streams on Earth. That's when the pattern was cracked. Each group of pulses aligned to a shifting harmonic, consistent with phase key shifting. This isn't found in nature. It's a known method in communication systems to embed data inside a waveform. The kind used by artificial systems to transmit information without altering amplitude or frequency. The comet wasn't just venting, it was encoding, and whatever it was encoding, it was aimed backward, along its flight path, not toward the Sun, not toward Jupiter, but back across the direction it had travelled. This changed the entire framing of its movement. Instead of assuming the object was just passing through the solar system, scientists began considering a terrifying alternative. 3I Atlas might be leaving behind a trail of data, a communication tether, a way to mark its path or interact with something trailing, or following, behind it. The timing of the shift also lined up with the stabilization event and the magnetic anchor deployment. This was no isolated phenomenon. 3 interlinked anomalies in less than 90 minutes. The pattern was unmistakable. NASA encoded the event under anomaly 13E as timed, structured particle phase emission with no known thermodynamic trigger. Further modelling revealed a disturbing amplification effect. As the emissions phase shifted forward, their coherence increased, meaning not only were the pulses becoming more organised, but the energy efficiency of the ejections was rising. Instead of random ejection bursts, 3I Atlas was now coordinating its particle outflow with rising precision, like it was syncing with an external rhythm, or preparing to transmit something larger. Engineers from the Deep Space Network proposed a final test. They aimed a tight-band microwave pulse at the object timed with the peak of an emission cycle. What returned was faint, but unmistakable. A delay pattern in the reflected signal, consistent with feedback, as if the comet had acknowledged the pulse. It's one thing to emit particles, it's another to time them, but to alter that timing on a moving schedule, that's intent. And now the emission seemed to respond. Something inside 3I Atlas is accelerating its own clock, and whatever it's trying to say, it's getting closer to finishing the sentence. Just after the structured particle emissions reached their steepest phase shift, something inside 3I Atlas visibly changed. Not in the outer coma, not in the magnetic field, but deep within, where the object's jets are thought to originate. At exactly 6:14 UTC on November 26th, infrared telemetry from the Lagrange 2 observational dome captured an unexpected thermal inversion within the core channel. For over 12 minutes, the heat signature that had traditionally followed a single axial direction, outward toward the tail, reversed. What was once outflow became inward motion. The moment was unmistakable. Plumes that had radiated from the sun-facing hemisphere were now collapsing inward. The ejected gas slowed. Particles redirected. The thermal vectors folded back toward the core, as if the object were inhaling its own emission. That's not a glitch in radiation. That's a change in flow mechanics. Scientists initially suspected a venting collapse, a structural collapse in the conduit systems within the comet's body. But spectral analysis ruled that out. The returning gases showed no fragmentation. In fact, they were cleaner, stripped of excess dust, more thermally uniform and moving with precision. In natural systems, jets are chaotic. They respond to heat, spin, and external pressure. But this behavior didn't match anything chaotic. The reversal occurred in 3 symmetrical bands, spaced evenly around the comet's core axis. It wasn't a collapse. It was a reversal in phase. More disturbing, the internal jets didn't reverse permanently. They oscillated. For 4 full cycles, each lasting 11 minutes, the flow reversed, returned to normal, and then reversed again. Each time, the temperature profile sharpened. It was as if the system was learning from itself, optimizing. By the 3rd oscillation, ESA's interferometry platform detected wavefront harmonics matching those found in pulse jet engines, systems that regulate thrust by alternating internal pressure and backflow. These are used in experimental propulsion and atmospheric modelling. 3i Atlas isn't atmospheric, it isn't in a lab, but it's now exhibiting engineered fluid dynamics. Theoretical models show that such jet reversals, if deliberate, could serve multiple purposes: thermal equalization, internal mapping, or something far more complex, like material intake. If the internal jets were connected to intake valves, they may be pulling in previously ejected particles for processing, refolding, or staging for release. NASA designated this sequence as anomaly 13J, reversible, oscillating jet behavior originating from within the object's core, with no known natural cause. It was the most explicit internal system behavior observed so far, and it didn't happen in isolation. Each jet reversal coincided with the phase pulses from Chapter 11, as if the object was timing its internal flow with external emissions, like a speaker pulling back before a louder note, like a system calibrating for pressure, for rhythm, for clarity, before activating the next stage. That's what made it so unsettling. The object isn't just stabilizing, it isn't just anchoring, it's breathing. And that breath, slow, symmetric, deliberate, is now guiding both mass and energy. Something within the heart of 3i Atlas is cycling back. Not venting, not exploding, processing. Whatever this thing is doing, it needs to reverse before it moves forward again. At 6:38 UTC on the morning of November 26th, a new signal emerged, faint, geometric, and completely unlike any previous anomaly. It wasn't thermal, it wasn't magnetic, it wasn't even visible in the traditional sense. It was gravitational. Using high-frequency gravitational wave monitors, originally designed to detect solar flares interacting with deep space arrays, NASA's L2 helioscope registered a weak but repeating distortion surrounding 3i Atlas. The signal was barely measurable at first, but it grew stronger every 11 minutes, in lockstep with the previously observed jet reversal cycles. When researchers mapped the wavefronts, the results stunned everyone. The distortion wasn't radial, it wasn't chaotic. It followed a nested geometric pattern, a lattice of intersecting wave paths forming perfect internal triangles and hexagons, expanding outward in 3 symmetrical shells. It was as if the object was housing multiple energy layers within itself, each nested inside the next like a Russian doll of force fields. And none of it made sense. There is no known natural mechanism that could cause this kind of stable energy lattice to form inside a spinning outgassing object. Internal density variation? Maybe. Electrostatic fluctuations? Unlikely. What made this impossible to explain was the lattice's coherence. Every shell maintained shape even as the comet rotated, pulsed, and shifted its internal jets. It wasn't breaking apart. It was maintaining structure. Each layer of the lattice had distinct resonance properties. The innermost layer pulsed at 1.3 Hz, the middle layer at 0.9. The outer, broader shell registered a pulse every 78 seconds, matching the known frequency of the emission phase shift observed earlier. The deeper scientists looked, the clearer it became. The energy lattice wasn't just passive, it was coupled with the comet's behavior. Jet reversals? Matched. Magnetic field anchoring? Matched. Particle emission rhythm? Matched. The entire object was acting like a multi-layered resonator. In practical terms, that means 3i Atlas was now behaving like an engineered containment system. one that stores energy not in tanks or cores, but in spatially organized wave structures. These nested energy shells could, in theory, absorb, stabilize, or even reflect forces acting upon the object, including solar radiation, particle collisions, and electromagnetic feedback. It was behaving like a field-based reactor. Engineers from ESA proposed a radical theory. If the energy lattice inside 3i Atlas was purposefully structured, it could be used to store and release energy in timed intervals. That would allow the object to function like a capacitor, not electrically but gravitationally. It could be building toward a release point, a phase change, or a deployment. That led to one question no one wanted to ask. What happens when the outer shell collapses? If these energy layers were being compressed or altered by the object's own behavior, jet activity, magnetic anchoring, internal rotation, the final stage might not be containment at all, it might be activation. NASA officially classified the discovery as anomaly 13K, the nested energy lattice, fully symmetrical, multi-frequency, internally coupled to emission cycles and jet behavior. This was no longer just an object passing through the solar system. It wasn't just reacting. It wasn't just maintaining structure. It was building something inside itself, something with structure, timing, memory, and pressure. Whatever lies within 3i Atlas isn't solid, or liquid, or gas. It's wave-formed, locked inside repeating patterns of energy, and those patterns are starting to tighten. At precisely Yo 7:41 UTC on November 26th, after 4 hours of uninterrupted tracking, the European Space Agency's Mass Gravity Recon team published a silent update to the Lagrange Deep Field database. No press release, no commentary, just a string of numbers, mass readings, volume estimates, and comparative ratios. It took just 3 minutes before an astrophysicist in Geneva raised the alert. These values are off by entire orders of magnitude. The reported mass density of 3i Atlas, derived through synchronized gravitational lensing and motion decay models, didn't just deviate from comet norms, it defied the category itself. Based on its apparent size, nearly 34 kilometers in core diameter, with a coma spanning hundreds more, the expected mass should have fallen within the upper bracket of icy megacomets, roughly 1.2 × 1015 kilograms. But the readings suggested a mass closer to 3.6 × 1013 kilograms, a fraction of the expectation. That means one thing: 3i Atlas is too light for its size, and not by a small margin. If the numbers hold, its density would be less than that of aerogel, an ultralight synthetic material used in aerospace insulation. And yet, the comet is surviving extreme solar exposure, high-velocity impacts, and structural inversions without disintegration. This is a physical paradox, something that large, with such low density, should not be intact. So teams dug deeper. Microwave resonance scans confirmed the object was not hollow, at least not in the traditional sense. The core exhibited layered density gradients, but no true voids. That left one remaining explanation. The material of 3i Atlas must possess non-terrestrial compression properties. One working theory is that the mass is distributed along a nonlinear geometry, meaning the interior is composed of ultralight but highly resilient structural lattices, perhaps similar to negative index metamaterials. These materials have no known natural origin, but have been theorized in advanced materials science for decades. But this leads to a larger problem. Comet models depend heavily on mass density alignment to predict behavior: orbital decay, fragmentation under stress, response to solar wind. If 3i Atlas doesn't follow those rules, it could maneuver, absorb force, or redirect energy in ways no comet should. More unnervingly, the density measurements shifted slightly over time. Over a 6-hour observational window, the total mass appeared to increase by nearly 1.4%, without a corresponding gain in visible volume, which raises the unthinkable: is 3i Atlas generating mass from within? There is no known astrophysical mechanism that would allow an object to increase mass without external accretion. No gas clouds, no collisions. This left two working possibilities. Either the internal structure is contracting inwards, densifying its core lattice, or it is drawing energy into mass through a process beyond current physics. NASA quietly classified this anomaly as anomaly 13M, ultra-low density mega-object with increasing internal mass index and stable surface integrity. deviating from all cometry predictive models. From that moment forward, it became clear 3i Atlas is not bound by the rules of comet behavior. It is not degrading. It is not following a passive course. It is stabilizing, compressing, and perhaps even changing form. And any object that can violate the mass density rule while holding shape, heat, and rotational symmetry is not just strange, it's strategic. At 8:04 UTC on the morning of November 26th, deep space monitors from both the Indian Space Research Organisation and the United States Deep Sky Array recorded something that initially looked like a data drift. It wasn't a drift, it was a delay. The anti-tail of 3i Atlas, the luminous forward-pointing trail caused by fine dust particles pushed along the object's orbital path, suddenly lagged behind, not by much, just a few arc-seconds, but enough to trigger red flag markers across 5 observatories, and then, just 19 minutes later, the tail snapped forward, as if being pulled by an invisible tether. This wasn't turbulence, it wasn't solar wind variation. Both factors had been stable for over 6 hours. What happened defied the behavior of every anti-tail ever recorded in cometry science. In standard physics, the anti-tail is a byproduct of particle mass and orbital motion. It forms slowly, with consistent lag time based on dust size and ejection velocity. But what 3i Atlas showed was nonlinear movement. The particles didn't drift. They held, then moved synchronously. That means something forced them into coordinated suspension, then activated a forward acceleration. When ESA's particle field modelling team ran the telemetry backward, they discovered something even more unusual. The particles in the anti-tail weren't simply catching up, they were overshooting the expected trajectory by over 6.3%. That acceleration required energy input, but from where? One hypothesis emerged quickly. The tail was no longer just a dust trail. It was interacting with the same wave-structured energy field seen in the nested lattice event. The tail's particles were being pulled, not pushed. That meant 3i Atlas wasn't losing material randomly. It was affecting its own field across space. And here's what makes it even more bizarre. Just before the tail surged forward, gravitational field distortions were recorded. Faint, but unmistakable. Not toward the object, but away from it. As if the comet had generated a temporary negative gravity well in its forward path, pulling the anti-tail forward like a slingshot. The result? An anti-tail that no longer obeys particle physics, but responds to internal field control. NASA officially labelled the event Anomaly 13N, delayed anti-tail activation followed by energy-enhanced forward acceleration, consistent with field synchronization and gravitational asymmetry. But behind the cold language of classification was a very real implication. Something inside 3i Atlas can manipulate surrounding matter. Not just eject it, not just shape it, but suspend, delay, and then accelerate it, with timed control. That is not passive behavior, that is field logic. It now appears that the anti-tail is not just a byproduct of motion. It may be a sensing array, a projection, or even a directional energy armature, guiding the object's movement through gravitational anchors we don't yet understand. Every comet leaves a trail, but 3i Atlas? It reaches forward, waits, and then drives. At 08:22 UTC, during a deep-frequency radar sweep performed by the Lunar-Based Interferometric Scanner, LBIS, something unexpected happened. A pulse was returned. Not a faint scatter, not a fuzzy boundary, but a clear echo, from within. 3. Atlas had just rotated past the 31-degree marker of its longitudinal axis. At that moment, the outbound radar pulse, tuned specifically for submaterial density mapping, entered what should have been a dense segment of the object's mid-core zone. Instead of slowing down or scattering, the signal passed through with near-zero attenuation. Then, it bounced back, and not just once. It reverberated, producing a faint but repeating return signal at 1.92-second intervals, like sound echoing through a cathedral dome. This was not noise, it was geometry. The signal wavefront returned a map of an internal cavity, approximately 4.8 kilometers wide, with smooth interior curvature and reflective gradients along all sides. This was not a porous rock pocket or a chaotic collapse chamber. The radar echo mapped a hollow segment, consistent in shape, symmetrical in angle, and impossibly stable given the surrounding pressures of the comet's spin. Scientists immediately ran recalculations. A hollow object of that size moving at current velocity should have collapsed under the shear stresses of both jet ejections and gravitational flexing near Jupiter's corridor. But it didn't. Instead, it held form, absorbed shocks, and even produced internal wave reflections consistent with energy containment. That's when a second anomaly appeared. The echo signature wasn't clean, it came modulated. Instead of a standard decay curve, the returning pulse was fragmented by timed intervals, precisely 440 milliseconds apart. This pattern was repeated 4 times in each radar return cycle, forming a 1-4-1 rhythm. Experts in harmonic resonance flagged it immediately. The pulse pattern mirrored known internal chamber reinforcement patterns found in controlled acoustic environments, like those used in resonance chambers on Earth to prevent standing waves from collapsing signals. That meant one thing: this segment wasn't just hollow, it was tuned. That opened the door to a radical possibility that the cavity wasn't a weakness, but a mechanism, a deliberate energy-reactive chamber designed to manage pulses from within, perhaps to house, redirect, or even amplify internal forces. The ESA tagged this finding as anomaly 13O, echo-mapped internal cavity with symmetrical form, acoustic reinforcement patterning, and time signal modulation suggesting engineered purpose. But the real implication was far more sobering. This wasn't erosion. This wasn't accident. This was architecture. A self-reinforcing internal space, protected by the surrounding shell, holding resonance properties and reflecting energy back in a perfectly timed pulse. That structure should not exist in a natural comet. And yet, there it was, spinning through our system, echoing back, responding, stable. Whatever lies inside 3i Atlas may not be solid. It may be signal. At exactly 0847 UTC on November 26th, high-resolution spectrographs aboard the IRIS-E array captured a rapid increase in plasma, emissions from the trailing side of 3i Atlas. At first, it looked like a standard thermal recoil event, bursts of ionized gas ejecting from within the object's layered coma. But when analysts broke the emissions down frame by frame, they uncovered something mathematically impossible for a natural body. The plasma jets were firing in prime number intervals, not random, not harmonic, not chaos, but a structured pattern: 2 seconds, 3 seconds, 5 seconds, 7, 11, 13, 17, and then the sequence reset. It was as if the object was counting. This discovery came from a signal analyst within the JAXA Deep Trajectory Group, who noticed an unusual harmonic decay when filtering infrared emission pulses. Upon closer review, the decay timings weren't symmetric, but rather matched a known distribution curve of prime gaps, those intervals between successive prime numbers. This behavior has no precedent in cometary science. Natural jets from comets are driven by solar heating, internal pressure, or chaotic fracture ejections. They appear randomly and decay over time, but 3i Atlas was releasing plasma in a rhythm tied to mathematical constructs not generated by nature. More unsettling, each plasma pulse emerged from a slightly different location on the object's body, distributed around the surface in a spiral arc. That spiral, when mapped three-dimensionally, aligned with the Golden ratio, yet another indicator of purposeful design rather than random geology. What could produce prime number timed pulses? One explanation floated internally: computational architecture. On Earth, signal beacons and digital systems often use prime number encoding to minimize signal interference. It's a pattern used in deliberate communication, often employed in SETI research to identify potential non-natural signals from space. In that context, this was no longer just a plasma event. It was possibly a signal. The jets weren't just venting heat or pressure, they were broadcasting something. And the prime number intervals might be the key, a fingerprint of intention, a way of proving the pulses aren't random. In the words of one NASA coder, prime numbers are the handshake of logic-based systems. They're the signal that something is thinking. But there was more. Each pulse carried with it a microfluctuation in the surrounding magnetic field. The field would spike just before each prime-numbered interval, as if the object was preparing, or charging, before releasing energy. These microfields were too weak to affect external systems, but strong enough to imprint on high-sensitivity magnetometers. NASA classified this as anomaly 13P. Synchronized plasma emissions at mathematically significant prime number intervals, accompanied by predictable magnetic precursor fluctuations and non-random spatial spiral distribution. In short, this was not behavior. This was protocol. A cosmic object timing its energy, released to prime number intervals, spreading pulses across a mathematically ordered shell, and modifying its magnetic footprint in anticipation. That's not a rock, that's logic in motion. At 09:02 UTC, during a synchronized attempt by the ESA, NASA and JAXA to scan the internal layers of 3I Atlas using deep penetration radio frequencies, an anomaly occurred. The signal didn't return, and not because the object was too dense, but because it was interfering back. A thick band of electromagnetic static wrapped itself around the core frequencies, not absorbing them, but scattering and corrupting them mid-transit. That's not a natural interference. That's intentional obfuscation. All three agencies confirmed standard radio waves, across all bands, failed to penetrate beyond the mid-shell layer of 3I Atlas. The implications were staggering. Even the densest known comets allow partial penetration by long-wave radio, enough to return fragmentary data or internal noise. But in this case, no signal got through. Instead, every probe pulse returned with sharp edge echoes, short, garbled returns saturated with what appeared to be internal phase noise. But what's phase noise? It's a distortion pattern seen when a system, artificial or organic, emits timed interference at regular harmonic offsets. In human engineering, this is seen in secure satellite encryption fields or cloaking technologies where sensor spoofing is required. So why would a comet do this? Unless it's not a comet, or at least not only one. Several layered disruptions were detected, each one tuned to cancel out different bandwidths. From ultra-low VLF to microwave-range radar, every single attempt was scrambled. These weren't naturally occurring ion storms or dust echoes. They were structured noise fields, resembling what encryption engineers call active nullification zones. That means 3I Atlas is not just radiating noise, it's suppressing clarity. And here's what's worse. Shortwave detectors, orbiting 210 kilometers above Lagrange point 2, reported reverse phase shadows, meaning that the object wasn't just blocking signals, it was sending back distorted reflections, bouncing them back to deep space on unpredictable frequencies. That's not chaos, that's counter-surveillance, a security system. When ESA simulation teams modeled the effect, they realized the outer shell of 3I Atlas might be covered in a disruption lattice, possibly composed of fine, electrically conductive particles arranged in a shifting web of reactive nodes. This lattice would be invisible at visual wavelengths, but absolutely hostile to radio. It would confuse, jam, and reflect every attempt to see what's inside. And that implies intent. NASA officially classified this phenomenon as anomaly 13Q, structured electromagnetic interference field surrounding core, resulting in full-spectrum radio suppression and reversed reflection emissions beyond L2. In other words, we're not allowed to see inside. There is no other object in the known solar system, natural or artificial, that reacts like this to deep radio probing. Not asteroids, not dormant comets, not even the most energetic plasma bursts near Jupiter's magnetic arcs. Only 3I Atlas. And that leaves us with one sobering possibility. Whatever is within does not want to be observed. Not from Earth, not from orbit, not from any angle. It is silencing its footprint, not by absence, but by deliberate distortion. At precisely 21 UTC, a multi-agency solar telemetry sweep revealed something that stunned plasma physicists across 3 continents. As a sharp stream of solar wind struck 3I Atlas, clocked at over 540 kilometers per second, the object didn't just absorb the impact or flare as most comets do. Instead, it adjusted its angle. Not chaotically, not by tumbling or rotating out of control, but by pivoting in what appeared to be a controlled angular response to the direction of the solar wind. Using long-range telemetry from the Solar Heliospheric Observer, SHO, and real-time data from the Parker Solar Probe, researchers measured a 4.7 degree angular shift in the object's rotational axis, timed exactly 3.2 seconds after the wind front made contact with its forward coma. To be clear, no known natural object responds this way. Ordinary comets flare, they spin erratically, they shed particles unevenly. But 3i Atlas adapted, reorienting itself in a smooth, non-ballistic arc, aligning its densest core face away from the solar vector, while redirecting its plasma trails into a more stable configuration. Why would it do that? A leading theory emerged almost immediately. 3i Atlas is exhibiting vector shielding behavior, the same kind used in spacecraft attitude correction systems. The implication: it is not simply reacting to energy. It is calculating pressure gradients, predicting field stress, and adjusting its orientation to minimize destabilization. But it gets stranger. Just before the shift, sensors detected polarized emissions near the object's equatorial band. Faint electromagnetic pulses aligned with the incoming solar trajectory. This polarization burst occurred milliseconds before the object moved, suggesting it was not only aware of the incoming wind, but had pre-processed its trajectory. Essentially, it anticipated the hit. This turns a reaction into a pre-programmed countermeasure, and the data doesn't stop there. As the solar wind washed over the object's surface, the entire outer coma layer pulsed once, a ripple effect spreading across its illuminated shell. Within moments, the object returned to its previous vector alignment, as if the pivot had served its purpose and was now being reversed to resume optimal trajectory. NASA labeled this behavior Anomaly 13R, preemptive angular adjustment in response to solar wind pressure vectors, accompanied by electromagnetic predictive signature and real-time structural repositioning. No rock does this, no ice ball, no cloud of gas and dust. Only engineered systems, those with dynamic feedback loops, inertial dampening, and predictive correction software, respond like this. That raises an uncomfortable possibility. 3i Atlas may not be travelling through the solar system, it may be navigating it, and if it's adjusting itself in real time to external energy vectors, that means it's maintaining operational control of its posture relative to the Sun, the one force that no natural body can defy without disintegrating over time. But 3i Atlas isn't degrading, it's optimizing. With every solar interaction, it seems to be learning, shifting, calculating, and if it's navigating, then it's headed somewhere specific. At 0939 UTC, the Hubble Space Telescope, in tandem with the ASA's dust polarization arrays, captured a frame-by-frame breakdown of 3i Atlas's internal motion signature, using enhanced particulate tracking. The results were unexpected. While the outer surface of the object maintained a slow, clockwise rotation, spinning at an average of 0.9 degrees per minute, the internal dust cloud visible through high-energy lens scattering was moving in the opposite direction, counterclockwise, at nearly twice the speed. This isn't normal, in fact it's impossible, under natural conditions. In physics, dust within a rotating object typically follows the angular momentum of its shell, unless external forces or energy gradients cause disruption. But in this case, the dust isn't just slightly misaligned. It's forming a stable, reverse gyroscopic system inside the core, as if there are two mechanisms at play, two distinct systems. The rotating dust particles, analysed via light scatter profiles and absorption delays, move with such synchronization that their motion can't be explained by turbulence or fallback from gas jets. Instead, it behaves like a deliberate rotational engine, slowly reversing internal mass to counteract surface momentum. This type of motion exists in only one class of systems on Earth: stabilized satellites. Artificial satellites often include a reaction wheel, an internal spinning mass that rotates counter to the satellite's outer body, helping maintain its orientation and resist external forces. The fact that 3i Atlas mirrors this setup, in scale, timing, and energy conservation, raises a chilling question. Is this object using internal mass redistribution to stabilize its flight? Further analysis revealed that the dust wasn't uniform. It separated into layers, the heaviest particles closer to the nucleus, with the lightest closer to the central cavity. And these dust shells moved not only in reverse, but also in harmonic waves, rising and falling in density as they rotated, almost like engineered internal dampeners. One scientist from JPL summarized it like this: "This isn't just motion, this is calculated inversion." The outer shell absorbs solar wind, maintains shape, and flares in the expected direction. But inside, a silent reverse engine spins, invisible to the eye, but traceable in the dust, like a whispering code written in particles. NASA flagged the phenomenon as anomaly 13S, internal counter-rotational dust dynamics opposite to surface spin, structured in layered density shells with phase-stable harmonic wave formation. But it wasn't just the movement that disturbed the analysts, it was the consistency. Across 7 different observational windows, the counter-rotation never fluctuated more than 0.1 degrees. That level of stability implies energy input. Something, or some process, is keeping the internal dust field precisely timed, like gears in a mechanism that must not fall out of sync. Which brings us to a final terrifying realization. 3i Atlas may not be one object. It may be a shell and surrounding a core that operates by entirely different physics. The outer layer gives us the illusion of a drifting comet, but inside it's rotating on its own logic, its own rhythm, its own agenda. And if it's controlling its interior, actively, precisely, then it's more than a mystery. It's a system. At 9:47 UTC on the morning of November 26th, a quiet but paradigm-shifting alert was triggered inside the ESA's Gravitational Anomaly Monitoring System, located beneath the Pyrenees. For the first time in its operational history, it registered micro-variations in local gravitational pressure, but not from Earth's crust or seismic activity. The signal was extraterrestrial. And it was moving, and it was coming from 3i Atlas. In real-time correlation with orbital data from the LISA Pathfinder platform and a mirrored alert from China's Tianjin detector, all gravitational field measurements pointed to a moving, rotating source emitting pulses of weak gravitational distortion. The epicenter? The inner core of 3i Atlas. This wasn't gravitational lensing. This wasn't background distortion from solar plasma. This was active, coherent field output. Researchers immediately ruled out mass ejection or crustal collapse. The frequency of the anomalies wasn't tied to impact events or velocity shifts. Instead, they were pulsed, slow, rhythmic variations in local spacetime curvature, arriving every 2.4 seconds, almost like the heartbeat of something immense and deliberate. This changes everything. In astrophysics, gravitational disturbances typically require colossal forces, collapsing stars, merging black holes, or neutron star collisions. But 3i Atlas, no larger than a city, was emitting a miniaturized gravitational signal, one that matched no natural precedent. One theory, quietly circulated within internal ESA documents, suggested the object may contain a compressed energy structure, possibly a rotating toroidal mass of high-density material, similar to artificial gravitational field generators proposed in early Alcubierre models. If true, this would make 3i Atlas the first object in recorded history to exhibit active gravitational modulation, and it would explain much of its previously recorded behavior, the angular shift in response to solar wind, a gravitational gyroscopic effect, the reverse internal dust rotation, a mass field stabilizer counteracting surface spin, the radio jamming shell, a secondary containment layer for gravitational field leakage. All of these, when seen together, suggest one thing. 3i Atlas is manipulating mass, from within. NASA flagged this event as Anomaly 13T, emission of weak gravitational pulses from central nucleus, frequency stable, non-chaotic, and directional. And here's the most disturbing part. The pulses began only after 3i Atlas entered the heliocentric zone near Jupiter's orbital belt. That means it was silent before, and is active now. Which leads to a chilling implication, that the object may have been in a dormant state, waiting for something, a threshold, a proximity, a signal, and when it crossed it, it began to breathe. One researcher at JPL, reviewing the pulse logs, described the signal pattern as low-level gravitational flexing, adding, "If it were artificial, this is how you'd start testing a gravity engine. You'd pulse at low amplitude to watch the universe react." What could do this, we don't know, but it's not dust. And it's not debris. It's something with an engine at its core, and now that it's pulsing, it may not stop.